q14 has given us a Cartesian equation. It's y in terms of x instead of x in terms of y, but we'll worry about why they've done that later. And they've just asked us to find dy by dx, or the value of dy by dx at the origin. So I'm going to, even though this is asking for dy by dx, I'm going to do dx by dy so that I don't have to do any rearranging. And I'm going to differentiate this with respect to y. So that's going to be a little chain rule. We're going to pretend that this is a y and differentiate it, which would be 4 cos 2y, but then I need to times by the 2 as well. So I'm getting 8 cos 2y for dx by dy. But that means that dy by dx is the reciprocal of that. So if I flip this, then I need to flip this. So 1 over 8 cos 2y. At the origin, I can usually be substituting x, but here we need to substitute in y. Dy by dx is going to equal 1 over 8 times cos of 0, and cos of 0 is 1. So at the origin, the gradient of the tangent is an eighth. Part B says use the small angle approximation for sine 2y. That's in your formula booklet. We know that sine theta approximates to theta, so sine 2y will approximate to 2y. To find an equation linking x and y for points close to the origin. So we're just going to swap sine 2y for 2y. So we've got x is equal to 4 times just 2y. So that's x is equal to 8y, or we could rearrange that and say y is equal to an eighth of x. Part 2 of the same question, so that's part 1. Part 2 says explain the relationship between the answers to A, which was that the gradient at the origin is an eighth, and the answer to B part 1, which is this equation here that we've got linking x and y. And you can see that the gradient value is an eighth, and the gradient of this is a straight line. The gradient of this straight line is an eighth. And what we've actually found here is we've found the equation of the tangent line of the curve, which is what the eighth shows. So we can say that the eighth is the gradient of the tangent of the line and that's from A, and y equals an eighth x is the equation of the tangent line at the origin. And finally, part C then asks us to find dy by dx again, but notice that this is in terms of x. We've got it in terms of y. We've got that dy by dx is equal to 1 over 8 cos 2y, and this is in terms of x. So essentially we need to make y the subject of this so that we can, well, we need to swap x for y basically, don't we? So how do we do that? Well, we know that x is equal to 4 sine 2y. We need to be able to write something about cos 2y so that we can swap it in here, something to do with x. And we know that sine squared plus cos squared equals 1, so that's what we're going to be aiming to use. So if I square this to get a sine squared, then we're heading in the right direction. So x squared will equal 16 sine squared 2y. If I divide by the 16, I've got what sine squared 2y is equal to. Now I know that sine squared 2y will equal 1 minus cos squared 2y. Sine squared 2y will equal 1 minus cos squared 2y. So if we substitute that in here, I don't need the brackets. And then we can add on the cos squared 2y and subtract the x squared minus 16, x squared over 16, and get that cos squared 2y is equal to 1 minus x squared over 16. And so we're nearly there, we just need to square root. So cos 2y, if we square root this, then we square root this, is equal to 1 minus x squared over 16. So if we substitute that in, we've got that dy by dx is equal to 1 over 8 root 1 minus x squared over 16, which looks great, but isn't how they want the answer. If you look at what they've got here, they've got an x squared without any fractional part to it. So we need to somehow get rid of this over 16. And the trick is to take out the 16 as a factor. So if I take out a 16th, I'm going to have 16 minus x squared. They're the same. If we multiply that back in, we get 1. If we multiply that back in, we get x squared over 16. But that was being square rooted. So this needs to be square rooted. And if we square root 1 over 16, we can split the root. So we've got the square root of 1 over 16 times the square root of 16 minus x squared. And this is just a quarter. So the square root of 1 over 16 is a quarter. And we've got that being multiplied by the root. So that's much, much better. That's what we were after. So I've now got to just bring that back in. So that's going to be 8 times a quarter of 16 minus x squared. We can multiply the 8 and the quarter together to get 2. So my final answer is 1 over 2 root 16 minus x squared.